In this video, we will be looking at the determinant of the matrix and its formulas. So here is the formula to find the determinant of a 2 times 2 matrix. The elements are represented as A, B, C, and D. When finding the determinant of this 2x2 matrix, we first take the descending diagonal A times D positions minus the products of the ascending diagonal positions. So it will be A times D minus C times B. Now let's try an example so that you can understand it better. Let's say a matrix M has the values 4, 2, 3, and minus 2 in these positions. And if we want to find the determinant of this matrix, we can substitute the elements in the formulas. So a times D would be 4 times minus 2. Minus and C times B would be 3 times 2. 4 times minus 2 is minus 8, and we subtract with the 6, which is the result of 3 times 2. We will get the determinant value of minus 14. Up next, we are going to look at the inverse of a 2 times 2 matrix. However, before that, we must first understand singular matrices and a unique matrix called unit, or identity matrix. First, we shall start with why singular matrices play an important role in the inverse of matrices. A singular matrix is a matrix which doesn't have an inverse, since its determinant is 0. Here's an example of this kind of matrix. As you can see, the determinant derived from it is 0. Therefore, there is no inverse for this matrix. For us to be able to find the inverse of a matrix, it must be non-singular. Second, we will now look at the unity or identity matrix. It is what we call a special 2x2 matrix, which has the elements 1, 0, 1, and 0, and is denoted by I. You can think of the identity matrix as it is the number of 1 in real numbers, since when any square matrix is multiplied with an identity matrix, the results doesn't change as shown in the example below. Now you can easily remember it by thinking of it containing a descending diagonals of 1s. There's also a 3x3 identity matrix, but we won't need to look at it for now. Finally, back on the topic of the inverse of a 2x2 matrix. For an inverse of a matrix to exist, the matrix must be non-singular. Therefore, the determinant of the matrix must not be equal to 0 for the inverse to exist. Now, from the formula for finding the inverse, we can see the determinant of the matrix coming into play. We use the reciprocal of the determinant of the matrix as the scalar multiplication for the matrix when the positions of the elements A and D are swapped, and then both the elements B and C are multiplied with a negative 1, or in simple terms, taking the negative of the element. Just like that, we can get the inverse of a matrix. Let's look at an example so that you will understand it better. Let's say that we want to find the inverse of matrix B with the elements minus 3, 2, 6, and 8. First, we find the determinant of the matrix, so we take the descending diagonal negative 3 times 8 and subtract it with the ascending diagonal 2 times 6. Therefore, this leads to negative 24 minus 12, which further leads to negative 36. Now we have our determinant. We can just plug it into the formula. Remember, we use the reciprocal of the determinant as the scalar in the matrix multiplication in the formula. Then, just like how the formula goes, we swap the positions of negative 3 and 8 and take the negatives of 2 and 6. So we get negative 8 over 36, 2 over 36, 6 over 36, and 3 over 36, which can be further simplified to negative 4 over 18, 1 over 18, 1 over 6, and 1 over 12. And just like that, we have now found the inverse of the matrix B.